So one of the ways they can add challenge to these maxima and minima questions is by giving it a context, and that's what they do in this fourth example. So Charlie wants to add an extension with a floor area of 18 square meters to the back of his house. He wants to use the minimum possible number of bricks. So he wants to know the smallest perimeter he can use. Dimensions in meters are x and y as shown. Writes down an expression for the area in terms of x and y. So the area is going to be the length times the width, so x, y, and the area they want to be 18 square meters. So the first relationship that we have there is x times y equals 18. Write down an expression in terms of x and y for the perimeter. So the perimeter are the block, the outline where the blocks are going to go, which is the three sides, because they're not going to block against the house. So I'm going to have 2x plus a y. So the perimeter P equals 2x plus y. C. Show that the perimeter P equals 2x plus 18 over x. So at the moment my perimeter equation has got a y in, so I need to eliminate the y, which I can do from 1 18 over x. Sub in 2, and the perimeter would be 2x plus, instead of y, 18 over x. D. Find the gradient function dp dx and the second derivative. So the easiest thing to do before we start to differentiate is to write this in index form, which would be 2x plus 18x to the minus 1. There's a 1 power on that. When it's a denominator, we can bring it up and change the sign on the index, so it becomes minus 1. So now dp dx will be 2 minus 18x, and then we subtract 1 from the power, so that will become 18x to the minus 2, and then the second derivative will be, that will be 0, multiply those, I get plus 36x to the minus 3. E. Find the dimensions of the extension that give a minimum perimeter and confirm that it is a minimum. So for minimum or maximum, dp dx equals 0. So bringing this back out of its index form, that means that 2 minus 18 over x squared equals 0. 2 equals 18 over x squared, dealing with a negative term there. Bring the x squared up, and I get 2x squared is 18, which gives me x squared as 9. X is the square root of 9, which is plus or minus 3. But in the context of this question, which is length, it can't possibly be negative 3. In context of question, x can't be equal to minus 3, therefore x equals 3. And if x equals 3, y must equal 6. Because 6 times 3 is 18. So what have I done? I found the dimensions of the extension. It's 6 meters by 3 meters, and confirmed that it is a minimum. So to confirm it's a minimum, I need to consider the second derivative. So if I call that 3 and that 4, in 4 d2p dx squared is equal to 36 over x cubed, and x is 3. Well, everything's positive there, so that's clearly greater than 0, and don't even need to evaluate it. It's greater than 0, therefore minimum. And when I write minimum, I just lose control with where my i's and my m's and my u's all exist, but they're all in there somewhere.